This is your second chapter, electricity, right? And I'll do this very quickly because there are some small theories that you need to know, right? All others are general knowledge, no? Right? And discovering electricity. And there is something about static electricity. You may have seen that term because this thing happens using the static electricity, right? And these are some stories. You can read these things, right? We use power packs or cells to generate the electricity. You know that one cell is 1.5 in the year 6 knowledge, right? Switches and the current in there, you can see one thing, the current, right? There is two things, the current and the voltage and the resistance. In here you have the things current, voltage and the resistance. There's two things. Current is the amount of electricity that is transferred. Voltage is the another store. This is another store. I'll explain it later, right? Current is measured by the ammeter, symbol is capital A, ampere unit. Voltage is measured by the voltmeter, capital volt, and resistor is the measured by the ohm. There is a relationship V equal IR. Is not in your syllabus. V means voltage, I means current, R means resistance. Now you may see there is a relationship. I'll explain it later. Write it in somewhere. You will need this furthermore in the lessons. The current is the amount of electricity is flowing around the circuit. Now if this is circuit, if you observe from here, you can see how many current passes through that point. That is current. The current carries energy to the bulb or other components. Components mean the things that use electricity, like it may be motor, buzzer, or speaker, something else. It is a use components. All that the components in here, right? Wire is a component, no, or everything is a component. Right? The electricity experiment. The current in the circuit is provided by cell or power pack. The cell generates the current and there is a flow to here and it goes to here. There is a circuit, right? And if what happens, there is a disconnect, the current comes to here and it will not complete its cycle and the current will not pass, the bulbs will not be light up. And in there you can use series circuits and the parallel circuits, right? And read these lessons, there are some small things. And measuring current, there is an ammeter. What are the things that you need to know? Now you have learned this before, right? We use ammeter to measuring current. The unit of the current is amperes, capital A, and ammeter connected to the circuit as seriously. You know seriously, right? Series means what? It connects as like this. Parallel means it connected as voltmeter connect as this, because if you connected a voltmeter in seriously, it act as open switch, so the current will not pass through that voltmeter, right? This is the series connection. This is the parallel connection. This, you know, the symbol is light bulb. This is the ammeter symbol. Voltmeter is symbol is this, right? And there is some thing that you need to know. If it is 12 ampere here, the current passes here and it passes through this ampere and the this ammeter, and the ammeter shows the value is 12 ampere and it passes 12 here, 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 right? It should not be changed. All are the 12 amperes, right? And I'll do some change to here. This is connected. This is another bulb. This one. Now what? Now we need to connect ammeter here, but otherwise we cannot measure the current, no, right? Ammeter is the current, and here I am connecting ammeter to, right? Assume there is 20 ampere in here. The first ammeter shows 20 ampere, and the 20 ampere comes with here, and there's a junction. The current is divided to two pathways, you can see. So if you know, if they have given it is 5 ampere, how many remaining current? 15 ampere. The 15 ampere current goes in this way, and this ammeter shows that is 15 ampere. You need to know the total is equal to the addition of these things, because in this junction it has divided 2. And if you connected here another ampere, it is 5 ampere too, because this is one branch, right? This is one branch. If you use another ammeter here, it is also 15 ampere, 15 ampere, 15 ampere, 15 ampere. In this branch all are the 15 ampere, whatever, where, it doesn't matter where you connected the ammeter. In this branch it is 5 ampere, in this branch it is 15 ampere, in this branch until here, until the junction, it is 20 ampere. Can you see, it comes 5 ampere, it comes 20 ampere after this junction, that is from here to here, that is what, again 20 ampere, right? That is the relation that you need to know. It doesn't matter how many lines there is. If it is another branch, now I am erasing this. Now if first one is 5 ampere, this is 2 ampere. Now what you can observe, in here the 20 ampere comes, in this line there is 5 ampere, after this line it's 2 ampere. So what is 5 plus 2 is 7, right? Now it comes 20 ampere, now just it passes 2 amperes. Now what is the how many amperes that remains, right? 20 minus 5 plus 2 is 7, right? It remains 13 ampere. So the 13 ampere is transferred through this line, in this line, right? 13 ampere. I hope it's clear. 20 ampere, 5 ampere, 13 ampere and 2 ampere, right? You can take the addition. The addition is equal to this 20 ampere, right? In here to here it goes 2 ampere, but in here it comes 13 ampere. When you connect another ammeter to here, it says the reading what is plus 13 in here, 2 from here, in there it is a connection. What is the value? 15 ampere, right? If you connected the ammeter to here, if it is ammeter to here 15 ampere, it's ammeter to here 15 plus this 5, it is 20 ampere, here to here 20 amperes. I hope it's clear, right? That's how you calculate the current. Now you know what is current, what is the unit of current, how to measure current, what is the device that we use to measure current. That's it. And the models in the science, we use some models to express something or show something that we cannot see. Can you see if it transfers electricity? No. There is additional point. If it needs to transfer in electricity, if we need to transfer electricity in a solid medium, there should be electrons. This is additional knowledge for you. If it is a liquid or aqueous, there should be ions. These are the things carries the current. Without electrons, a solid medium cannot passes the current, like you know that, right? In the non-metals, they expected graphite, graphite can be transferred electrons current, because graphite has electrons, free electrons. So graphite is a conduct that can electricity conduct. So non-metals are insulator because they doesn't have electrons, right? So if it needs to be transferred in liquid, there should be ions, right? If you need to know furthermore, search on some platform, you can learn, right? There are some two models you can see, right? In the cell, what is the job of cell? the cell the cell is the one who make the force to to help trans to help to travel the electrons, right? Without a battery we cannot generate electricity means traveling electricity means briefly traveling of the electrons or ions, right? In here say in here the cell, wait, now you can think about cell as this. In here cell as this, think about what is that. And here the wire is like this, the current wire is like this. And in a circuit there is a light or some components to use the current. In here this is act as the light bulb. In here the bell act as a light bulb, right? Now think about, there is some difference in SAM's and NET's model. What is that? In SAM's model the water does not be waste, but in NET's model the drawn thick balls will not travel furthermore. It is out of the story. Marbles, right? The marbles will not be travel in that flow anymore. But think about in Sam's model, it travels furthermore. Okay. And testing model, you can read these things, right? And physical model and abstract model, you can get an idea. Physical model you can touch it, abstract model you cannot touch it. It is like in the computer screen and the people's mind. There is a difference of the physical model and the abstract model, right? And models for circuits, right? And to do that, right, you know, metals are conductors, non-metals are insulators. But there is a non-metal, what? Graphite is made from the carbon, but graphite can transfer the electricity. And there is one thing made from the carbon, that is diamond is a non-metal too, but is very hard, right? And there is some two things, right? And there is a boiler and there is a radiator. You can see what happens here. Identify the things. That the boiler transfers energy to water and pump to the hot water. And what happens after it's in this radiator, it becomes cool and it releases energy, and again it goes to heat. This is used to heat up the homes, right? And think about and assume the things, what is act as battery, what is act as wires, what is act as the bulb. And think about this one, I'll explain this. There is a factory, there is a coal mine, and there is some crops. Now first of all you may think factory act as, now the first thing you may look at the fact, now your mind is factory generate something, no? You think factory act as the cell, you think coal mine act as the light bulb, the factories act as the wire, right? And when you exactly analyze this one, right, what happened without the what happened, think about the path. The arrow is from here, so coal mine generate the coals and goes to the factory, right? So think about, without a coal mine the factory cannot work, right? So coal mine act as the cell, the factory act as the bulb, right? In the models they are not exact items, but we can assume that this act as like this act as like this, right? That's a basic idea. And you have series and the parallel circuits, right? And how to identify it, series or a parallel circuit, right? Now the thing is, cut down the wire in some bulb. If there is many bulb, cut down the wire in bulb, right? when it's cut down your bulb, it acts as open switch, no? So if the all bulbs are turned off, the bulbs are in the series circuit, right? After it cut down, the first bulb is turned off, second bulb is still working, so the bulbs are connected as the parallel circuit. I'll explain this in my classes very well, but in here it's not time, right? I think you may learn it before. This is the simple idea. Okay. And you can identify here that the thing that I explained here, the 2 ampere is equal to the sum of these ampere, because in this is the junction, in this junction the current is divided to two pathways. After in here, in this one and this one, it combines again, so A4 should be 0.4. That's a small part. And I hope you have the ability to identify if they have given some circuit, if they have given a complex circuit, you need to know, identify which bulb are connected as series, which bulb are connected as parallelly. And there is an or switch, right? In the previous scenario, we connected things like we connected bulbs as seriously and parallel. In here, we connected switches as seriously and parallel. So if you connected bulbs in the series, it is AND. If you connected bulbs in the parallelly, it works as the OR gate. It is AND gate and the OR gate. The point is, now this is the graph for the AND gate, right? You know that if it is like this, we call this an open switch. If it is closed, there is a closed switch. In the AND gate, the bulbs works only in the scenario the both should be closed in here. If one switch is closed, it doesn't matter, the current comes from here and stops from here, it cannot pass through the X switch, right? But in the O gate, in the O switch, if Y switch is closed, there is a path to complete a circle. So you can see in the, this is a chart for AND gate, right? Now think about, I'm writing in here Y and the Z. In the Y and Z, if one switch is open, the bulb turned on, right? In here turned on, in here turned on. If it is, sorry, yeah, if it is if both bulbs are open, switches are open, the bulb is off. If at least one is closed, the bulb turn on, turn on, turn on. What is the requirement in OR gate? In the OR gate, at least there should be one closed switch. That is for OR gate. In the AND gate, what is the requirement? The both should be closed. In the AND gate, at least one should be closed. In the OR gate, this is OR gate, no, this is AND gate. In the OR gate, at least one should be closed. So in the OR gate, at least one. In the AND gate, both should be. And change in the current. You can change the current. You cannot control the current directly. That's why you control it by the voltage. Because according to V equal IR, right? V does not change the R term. So I is the current term. This is resistance. This is voltage, right? If V does not change the resistance, the one and only method that you can change the current is changing the voltage, right? Voltmeter should be connected as parallelly. This is the bulb. If you connected voltmeter to here as seriously, it act as open switch. The current flow will not, the current will not flow. And there is the unit voltmeter. And this is some change in the voltmeter. Now in the previous one, in the current, you may remember if it is equal to a path, right? If it is just one path, the current will not change in everywhere. there is a fixed value, but in the voltage the current is a fixed value for a branch, right? In this branch, if it is 4 volt, it is 2 volt. If it is another branch, now this is one branch, there is another branch, there is some component, right? If you make here, that is 6 volt, right? Voltage is difference in one path, right? It's not like before. In this path the total is 6 volt. In this path the total is 6 volt. Now think about it's another path. This is the third path, right? So in here it is 6 volt, in here it is 6 volt, in the third part it's 6 volt too, right? And you have some components. Now we have resistance. This is the this is the diagram sign, and if it is like this, it is a variable resistance that you can change the value of the resistance, right? But there is a fixed value. In here you can change the value of the resistance. And building robots, you can read this lesson, that's the easiest one. And careers in robotics, the next one, using electricity. You need to know electricity may cause hazards, and you need to if you need to work with electricity, if you need to take the advantage, is like a knife. You need to be very careful, because there is a great risk you may be die if it is electrical shock. No, it has something to do reduce your risk. Never touch the bare metal parts in plug. Never push things into socket. But in the modern switches, there is a protection, insulator protection, right? But it's better to not to do those things, the risky things, right? And do not plug too many things into one socket, because there may be overload and there may be burnings. Right? Never use something that has a damaged wire, because if the insulator part is damaged, you may shock. And think about, there is 3 wires. The blue color wire is neutral wire, the green color wire is the earth tongue, this one is the live wire. And the point is, in here we use in this component, what is this? This is the fuse. Why do you need to use a fuse? What is the advantage of using a fuse? If you use a fuse, when you use a fuse in 10 ampere, right, it passes 1 ampere, 2 ampere, 3 ampere, it passes 1 to 10 ampere. It's okay with 10 ampere. What happens if it passes 11 amperes? This is okay. If it is passes 11 amperes, the fuse is burnt, right? The fuse breaks, right? There is some small wire in there, small one, right? It burns, and after it burns, it will not pass current, it will not pass the current through that fuse. So your component cannot be used, because now the fuse act as an open switch. It is used for the security. Think about if your laptop is rated for 15 ampere, right? So in that case you need to use exact 15 ampere fuse. Why? Otherwise, now if you use 15 ampere fuse, if comes in 16 ampere, the fuse burned and protect your device, right? If you use 20 ampere fuse instead of 15 ampere, what happens? It passes 0 to 20 ampere current through the fuse. The fuse will not break. Then what happen? Your device is rated as 15 ampere, your device will out of work, right? So the fuses is used to protection of our devices. So you need to replace, if it's burned and if you need to replace the fuse, you need to replace exact value, right? Otherwise there will be not the protection to your devices, right? Fuses have ratings. Right, is 5 ampere, 10 ampere, 13 ampere, 15 ampere, 20 ampere. There is the thing. Here you can see number of fuses. So the 3 ampere fuses passes the range of 0 to 3 ampere. What happens if 3.5 or 4 ampere? The fuses burns. 5 ampere is valid to 0.5 ampere. 13 ampere is can use to 0 to 13 ampere. Right? Now think about what happened if you use in there. Now your device is rated for the 15 ampere, right? Now we talk about what happened if you use 20 ampere, right? It passes more current, your device will be out of work. And what happened if you use 10 ampere fuse, right? The device need 15 ampere, it requires 15 ampere. What happened if passes 15 ampere? Your fuse is again out of work. You have to replace again and again fuse. You cannot use the devices, right? That is the function and the use case scenario of the fuse, right? And a world without electricity. Now you know what are the things, right? So that is end of the part of the electricity. Right, you can join the next chapter with forces.